Hello, welcome to this PolyAnalyst training video. In this section, we'll be going over indexing, which is another important aspect of the text analysis process. Let's first define what indexing is and why it's so important. In text analysis, the process of indexing separates each word or lexeme, saves a list of the words and their positions in the text, and tags these with linguistic contextual information. Indexing is a crucial step that we perform after the data preprocessing stage, and we typically do this before we jump into the data-driven analysis stage. So the reason indexing is so important is because many of the techniques we use in data-driven analysis involve natural language processing. And in order for the computer to work with the data more efficiently, we need to provide positional, statistical, and linguistic information for the words in the text. This linguistic information, or context, is assigned based on certain lexical, morphological, and syntactic tasks that are performed in a single automated step when we use the index node. Now, in PolyAnalyst, the default semantic information is already included and ready for us to access, but we can also choose to add our own. Another thing indexing does is that it computes statistics about the use and frequency of words in the dataset. So what does this mean? Well, for humans, linguistic context also contains information that allows us to evaluate the significance of certain words. These are the things our eyes are drawn to when we scan for information. Now, computers can mimic that powerful effect of human cognition by computing the use and frequency statistics for each word in the dataset. And then the index node allows us to compile and export this information into a statistics dictionary. And in the next video, we'll see how this can make a big difference in tasks like keyword identification, which is the basis of the keyword extraction node. Now, as we mentioned earlier, text analysis nodes require that the text is indexed with all this statistical and linguistic context in order to perform natural language processing tasks. And depending on how we organize our workflow, this indexing may occur implicitly with the addition of a text analysis node or explicitly with the index node. Now, let's talk about the difference between implicit and explicit indexing using a workflow example. So the first difference is that implicit indexing occurs right before the first node that requires linguistic context for the text analysis in the workflow. When we attach and execute the entity extraction node here, the modify columns node right before it is re-executed to create an index. And this index is then saved for subsequent re-executions or subsequent text analysis nodes. So if I next attach a taxonomy node to the modify columns node, it won't need to re-index. Now, explicit indexing, on the other hand, occurs when we attach an actual index node. Now, the reason we'd want to perform and save an explicit index like this is because indexing is one of the most computationally intensive tasks that we have in our analysis process. And this is because it's involving going through each word in the text and assigning the linguistic context. So this is why it's important to understand where in our analysis this process occurs so that we have full control over the workflow execution process. And with explicit indexing, with the index node, we get this control. Now, another difference is that when we do implicit indexing, the indexing and the analysis take place together, which may take some time depending on the size of your dataset. This also increases the risk of losing our progress, or if an execution failure occurs or a system crash. However, with explicit indexing, we have the option of saving our index and progress before moving on to our analysis with a different node, since it's an individual process in a single node. Now, another difference is that when we do implicit indexing, the indexing and the analysis take place together, which may take some time depending on the size of our dataset. This also increases the risk of losing our progress if an execution failure or a system crash occurs. However, with explicit indexing, we have the option of saving our index and our progress before moving on to any other analysis with a different node, since it's an individual process in a single node. Another advantage of explicit indexing is that we have more flexibility when it comes to adding or replacing nodes. For example, if we wanted to replace the modify columns node with a filter rows node in the workflow on the left, we'd have to reindex. And we would definitely want to avoid that, especially when we have a larger data set. However, there's no need for doing this reindexing in the workflow on the right, since our index is already saved in that index node. Additionally, explicit indexing with an index node serves as a visual reminder of where our index is stored in the workflow. For example, if we need to go back to the data preprocessing stage for refining, it serves as a visual cue that we'll need to reindex afterwards. So it helps us allocate our time accordingly. Finally, we can configure the index node to parse the text according to certain preferences, which is something we can't really do with the implicit indexing. Thanks for watching this session. Up next, we'll begin going over some data-driven analysis techniques, starting with keyword extraction and linked terms.